Hi everybody, welcome to the 2020 APAC Groundbreakers virtual tour by the APAC OUC. This year our event will be biggest one ever done with 174 sessions including normal hands-on sessions, workshops and labs from 123 different speakers over 11 days. Also it would be cover sessions on 4 different languages. And please remember to register to as many of these sessions as you can. And all sessions will be available to replay as many times you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during the 2 weeks by posting questions or comments directly on the playback session page. Cool. I do want to say a big thank you to the Oracle user group, the Java user group, and then who made this event possible, as well as to our sponsors, the Oracle Groundbreakers and for CloudDB. Now for today's session, it's a very exciting one. So you want to run Oracle database on Kubernetes by Ron Ekins. Now please feel free to write questions at any time during the sessions in the Q&A tab at the Zoom session down. You'll find the Q&A section. So please feel free to add any questions you've got to that. And if we get time at the end of the session, we will come back to those and we will answer them. If we don't get time, we will connect through to you afterwards and we'll be in touch. Now, without any delays, what we're going to do is just switch over to Ron, and then Ron, up to you.
Oh, thank you, Anson. Let me just share my screen. Okay. Can you see my screen, Anton? Has it got orange?
Yes, that's perfect.
That's great. Okay. Good morning, good evening, good night, good afternoon, whatever time zone you're in. So welcome to my session. So you want to run your Oracle database on Kubernetes. So that's me. You can't see a video, so I thought I'd put a picture up there of myself. So Ron Ekins, I work in the office of the CTO at Pure Storage as a principal field solution architect, focusing on Oracle. Oracle Ace Director. There's my Twitter handle there at Ron Ekins, and I have a very active Oracle focused blog at ronekins.com. So Oracle Ace Director and Enterprise Architect. So hope you enjoy my session. So today's agenda, we'll do a quick introduction to Kubernetes and Docker to make sure we're all on the same page. And for those that are new to the subject, I'll introduce that. We'll talk about some of the Kubernetes concept which build upon Docker, Oracle and Docker, the history and the relationship there, and then where it changes when we start using containers for databases, the need for persistent storage. And one way of doing this is the container storage interface, the CSI driver. And then we'll end up just talking about running Oracle Kubernetes. Okay, so moving on. So introduction to Kubernetes and Docker. So what is Docker? So Docker's been around a while now, and we've been talking about it for a while. Still quite new for many people though. So it's a platform mainly used by developers to build, run and share applications. It's an easier way to package an application. And the way we do this, and the term we use is containerization. So it makes it portable. However, it's not that new. You know, we think of Docker and containerization as new, but we've been using it for a while with Linux containers, and you know, you can go further back with other technologies like Solaris zones. So LXC is one way of doing it, but you know, it's really aimed at developers. It was aimed to package applications and make them portable. Continues to gain popularity. KubeCon and the like, you know, these conferences are getting bigger and bigger every year, and we're not just seeing it in the developer space, we're now seeing it into production and used by operations teams. The reason for the uptake, a lot of it is because of the way it's built. You know, it's flexible, it's lightweight, it's portable, it's loosely coupled, and it's scalable. So all good things that we like to see in the database space. And finally, secure. You know, it has to be safe to use in production. So it ticks all those boxes, and that's the reason it's winning at the moment. So that's Docker. What about Kubernetes? So, you know, why Kubernetes? Where's that term come from? So Kubernetes is the Greek word for pilot or helmsman of the ship, and that's what it's doing. It's orchestrating. It's not doing the work. It's facilitating it. Also known as K8 and Kube. So when you hear people talk about K8 or see it written to K8, they mean Kubernetes. and Kube. So we get a bit lazy in IT. We don't always call it Kubernetes. So where does it come from? So the history of Kubernetes. So if you're a sci-fi fan, you might recognize some of those logos over those images. So it's based on Borg. That's what the top right picture is. And Omega. So it is a very mature technology. It was developed by Google back in 2003, 2004, written in C++. Google rewrote that as 7 of 9 and open sourced it, called it Kubernetes. And that was then ported to their language, Golang. So that's really where Kubernetes starts when we talk about it being the open source project that we know today. So it's general available, and we talk about the birth of Kubernetes was summer 2014. So still in IT terms and database terms, quite a young technology. But if you go back to 2003, it is obviously a lot more mature than that. So production ready. The first release GA was July 2015. And the latest release is 1.19, and that came out in August. So it has a very well-maintained release schedule and frequent updates. So you keep watching it and you'll see it's gone from 1.17, 18, 19 this year. So it does move on a lot and you have to keep up to date. So that's Kubernetes, that's where it's come from. But what about Docker? So people do get confused between Docker and Kubernetes. So Docker is the container platform. But it's not the only container platform, and more other container platforms are gaining popularity. So Kata, Cryo, Runc, Rocket, and Containerd are all other container platforms. Docker is still the most popular, but some of the others are gaining popularity also. And this is also true for Kubernetes. It's not the only orchestration platform. So Kubernetes is by far the biggest, but Docker Swarm, Rancher, Mesos, and Nomad are all alternatives. I guess because of Docker Swarm being an orchestration platform, that's where the confusion gets. Or is it Docker? Is it Kubernetes? So Docker Swarm is similar to Kubernetes, whereas Docker itself is a container platform rather than orchestration. So they're different, but they're complementary. They're not rivals, they're related. So Docker is the container platform. Kubernetes is the orchestration platform. So Kubernetes orchestrates platforms like Docker. So how big is Kubernetes? 77% of the market today. So OpenShift, Swarm, Mesos, Rancher, they all have a share, but by far Kubernetes is the biggest one. So why is Kubernetes popular? Why are we seeing this massive uptake? And really it's driven by the cloud. So whether that be Azure, IBM, Alibaba, Google, the Oracle Cloud, AWS, they all run Kubernetes. So this goes back to that point of being flexible and the run anywhere. It's very portable. So some of the concepts we need to grasp when we start talking about Kubernetes. So pods. So think of peas and peas in a pod. So a pea pod can hold one or more peas. A Kubernetes pod, a pod can hold one or more containers. So that's a great way of doing that. Some people put the picture of a whale, but a group of whales is a school, not a pod. So that's why a pea pod's better, probably analogy. So deployment. So this is the most common thing you'll see in the Kubernetes world. So it's a template, it includes replicas, and it actually describes the state or the desired state of how we're going to deploy our application. It supports rolling updates. Stateful sets adds a bit more logic, and also it enables and supports the ability to create persistent volumes within the stateful set. So it's a great way of actually packaging up in a solution and providing storage to that. Service. So this is how we interact with our container remotely. So this gives us the port mapping and namespace. So this is the logical isolation and the way we can have maybe a team working in its own space, so it's secure and it isolates resources from other users. So we'll be using all of these in our Oracle piece, isn't it? So configuration map. So this is how I manage my configuration, all my environmental variables. I can inject these at runtime into a container. So I use a config map and persistent volume claims. So for a database point of view, we want to make sure our storage is persistent. We want to make sure that our data persists between containers. So what's Oracle been doing in this space for the last few years? Well, we've got the Docker Hub, and we've also got the Oracle Container Registry. So Docker Hub hasn't been maintained for a while, so it's still got Oracle 12c there, but that's 3 years old now, and only has 12.2. So it's probably not the place you want to go now to get a Docker image. However, the Container Registry has recently uploaded 19.3 and also has still the 12.2 environment there. So that's there, and you can take that version and use that. But you know, there are, and that's great that they're there because you can use those without having to build your own. But for many organizations who want that flexibility, you know, Oracle also provide build scripts. So you can visit GitHub, go to the Oracle side of GitHub and drill into the Docker images. And there you will see build scripts maintained by Gerard to do different Oracle builds. So we can see 19C, we can see 18, Enterprise Edition, Standard Edition, and XE, as well as release 12 and release 11G. So a great number of build scripts there for you to use. So if you're using the XE, it will build the image and it will download the Oracle binaries for you, the free version for development and test. However, if you want to use Enterprise or Standard Edition 2, you will need to download the Oracle binaries in advance for the build script to work. So how does Oracle support this? So there's the MOS note. So always when you see a MOS note in a presentation, you know, go back and check it because they are living documents and they do move. But at the time of this presentation, you know, Oracle only support single instance Docker in production. But you can run RAC in a limited development and test environment. So single instance is good. So you can run Oracle in containers anywhere, but for Oracle for RAC, it's not production ready yet. And it's advised to only run that in test and development. And if you think 10 years ago, we had a very similar story with VMware. So it's the position today. It doesn't mean it will be that case going forward. So let's cross our fingers that we'll have RAC in the future. Okay, so that's a bit about some of the terms of Kubernetes and the background and what Oracle's doing with it. So why do we need persistent storage? Okay, so if we think about the difference between a container, a classic container that a developer uses, and a database. So containers were designed to be stateless, so that you throw them away and you don't care about it. They can be restarted at any time, and the loss of data isn't an issue because they shouldn't be stateless. They should be stateless. However, a database is stateful by design. We want our data to persist. Short life cycles versus long life cycles. So minutes, hours, and days for a container. You know, for a database, hours, days, or years. We're used to running application database for many years. So it's not normally considered to be a good candidate for containers. And for some of the purists, they would argue that you shouldn't put a database in a container because it needs to persist. It needs to be around for a long time. Treated like chickens. If one dies, just get another. You know, this very much this pets and cattle analogy that came out from the VMware world sort of idea of you look after your pets, but when you virtualize, you know, you treat them like cattle. However, you know, think about containers and databases. I've said chickens or members of the family. For a database, you know, we protect them at all costs. For us, it's about data security. It's about keeping it fit and healthy. So we do treat them like members of the family. We do get to know our data and our database. Location independent versus location specific. You know, whether that be your listeners, your application connectivity. You know, we're used to working with fixed IP addresses and host names and physical storage presented either locally, direct attached, or shared storage. So it's a very different sort of concept when we put a database there. Containers tend to be lightweight, you know, megabytes or gigabytes of memory, minimal storage I/O, and a little bit of network I/O. Databases are completely the opposite. Heavyweight applications, you know, gigabytes or terabytes of memory allocated, heavy storage I/O, and lots of network I/O. However, we can run our databases in containers now. So we know that we need to persist our data. So we need persistent storage. We want to make sure that when we stop a container, we don't lose our database. And one way of doing this is the CSI driver. So it's a standard. So there's the Kubernetes link there to persistent volumes. It's supported by many different storage platforms, and it provides a number of modes. So read write once. So a read write once volume is a great way of presenting block storage to a single instance database. So the volume can be mounted read write by a single node. Read only many. So a volume can be mounted read only by many nodes. And finally, read write many. So if we were doing a rack environment, that's when we would need to read write many. So these can be either block or file, and CSI supports both. So whether that be an NFS file system, and that could be for an Oracle applications shared directory, or block using ASM. So it supports both the read write many and single access. So what does this look like? So here's some YAML, so yet another markup file. So this is the way we describe information inside Kubernetes. This is how we present it. So we can create NFS volumes or block volumes. So just showing you here the way of laying this out. So here I'm creating an NFS volume. So I can give it some metadata, give it a namespace. So I'm creating all of my entries in its own dedicated namespace. Labels helps me to filter and to list just the right resources. So here I've got a database and a version. So it's my standard I use. So labels are user defined. And then a specification. So here I'm saying what storage class to use, and it's a read write many, and it's a file system. So that's a file system for NFS. Block, what would a block look like? Very similar. So here I've just got the same namespace, but a different database name for the name of the resource, some labels. I'm using a block volume, and then it's read write once. So this would be a block device presented to my container. And then we can also, from a stateless set, use the one that will build it and allocate in line. So what can you do with a CSI driver? So the standard supports the following features: the ability to provision storage dynamically. So we can create that on demand as we start our container up. The ability to take snapshots. So we can use these to protect our database, do point-in-time snapshots, ability to trial upgrades or do recovery. So that's all supported from the standard. And cloning. So we can take a snapshot to protect it, and we can also use that to clone another environment. So we can have our production database, and we can take clones and snapshots and spin up copies on demand, very lightweight. So how would you do this? So here is an example of cloning. So here I have my namespace and some my variables, my labels again, my specification, what it's going to be, and then a source. So it's a persistent volume claim, and that was the of data 183. So that's going to create a new resource called 183 clone. So that's my clone. And once I have that YAML file in place, it's as simple as kubectl apply -f for file and then the clone. And then that would create my persistent volume. And if I then describe that, I can see the block device has been cloned, and there's the capacity and the access mode. Read write once. It's a file system. Snapshots also supported. So we can use storage level functionality from our Kubernetes environment without having to sign on to the any storage platforms. And because it's a standard, it's the driver supports, there's drivers available for different storage platforms. We can have the same YAML file just by changing the storage class. So here I'm taking a snapshot, giving it a name, telling it what namespace, some labels, and that's a source. And that's going to take a snapshot of that volume. And then that does that, and that applies there, and I can see my snapshots being created. So I can create new volumes, and I can also take snapshots, and it tells me when it was created and what it was created from. Deployment. So on my blog, and I have some information about how you can do this yourself, how to get started. And also I've got some code on my GitHub repository. So here I'm using kubectl apply -f. So it's a file again, and there's my YAML file I'm using. So this is an 18C deployment. And here you can see that I've created a deployment, which is going to create a pod. And then I've created 3 persistent volume claims. So one for my data, one for my startup, one for my setup. The Oracle build script puts all the data for the database in this mount point and has 2 separate mount points. So one that it runs for the very first time called setup, and then whatever script you put in the startup will run every time the container starts. So that's good. And I've also created a service. So I've created my environment from one command. kubectl get deployment -n for the namespace. So I specify the namespace, and there you can see my deployments is ready, 1 of 1, and how long it's been up for. I can get the pods. So there's the pod in that deployment. So because I can tell it's a deployment because of the funny name at the end. If it was a stateful set, it would have just a number. So it's 1 of 1 and how long it's been up for. So we can get that, and we can describe that, and we can look into the logs for that container and see what it's doing. Kubernetes also has a UI, the dashboard. You can go there. So I can go into the dashboard, and I can see my persistent volume claims. I can see where they've gone, the size of them, the class, any labels that I've attached to those. So there's my 3 volumes, and then the sizes. So these were dynamically created without me having to visit storage platform or through my Kubernetes environment. And using the labels, here I am filtering to give me a report of all of the persistent volume claims in that namespace for version 183. So I've got scripts for 183 and for 19 as well. So there we have my data, my setup, my startup, all created. Filtered by the namespace. So that was my 18C deployment. So let's try it with a stateful set. So again, kubectl apply -f, stateful set YAML file, and the Oracle namespace. So I create it in there, and that's done that for me. I can see the pod. So I list the pod, but only want to list the 19.3 pods. So it's a way of filtering out other information, other pods that may be running my platform. So there we have that. I can see it's been running. I've got the name from my get pods. So there's my name there. So it's rather than the big long name, it's just got a 0 on there because that's the very first one. So I know the name of my pod, and then I can get the logs for that pod. And as it's starting up the very first time, I will see the startup of the Oracle container, where it builds it, installs it. If it's already there, subsequent startups, it won't have to do it again. It knows it's there. It sees the data files, doesn't recreate them. So there I can see the container starting. I can see the name of the database, and I can watch the logs. And I can go into the Kubernetes dashboard, and I can see that my volume's all been created without me having to do those in advance, all from my stateful set. So there's the name and the replica name, and there's the storage all there. All read write once, and then the sizes that are specified in my YAML file. So we've created our database, we've got that up and running, so we can shut a database down, we can start it up using the replicas. So scale, so this is for the deployment I created. So deployment, the name of the deployment, replicas 0 will shut the database down, replicas 1 will start it up. And the same for the stateful set. 0 to shut it down, 1 to start it up. So we can shut down and start up our database on demand. And it's persistent, the storage is persistent, our database is going to be there. We're not going to lose any data. Want to get rid of our database? We can do that as well. We can use a delete, Kubernetes control delete, and then that would get rid of the database. We can also relocate our database. So if we have a 3 or more node Kubernetes cluster, we can use kubectl cordon or uncordon to move a database. So we would uncordon a node. That makes that node no longer available. We can then stop our database, and it will automatically start up on I'll kill the pod, and it will automatically start up on another server. Once we've done our housekeeping on that server, on that node, we can then recoordinate it and make it available for other work. So to be in persistent, if we delete the database at the kube control level, it won't automatically delete the data from the storage platform. So you have to make sure you can do that so you don't shoot yourself in the foot. So you've got a bit of protection there. So we've got our container running and we've got our service running. So now we want to connect to it. So we can use kube control get service -n, the Oracle namespace again, and this will give us the services. So here I have my stateful set there, the Oracle 19C1. I have the port. So the 1521 is our listener, and that is the external port which Kubernetes has allocated to us. So we can connect to this remotely. So we don't have to really worry about the name or the IP address. They are in the container world, they're going to change depending on which node we're on. And we're talking not to the node, we're talking to the pod. So here's my, my port. And here for my laptop, you can see I'm using SQL+. I'm connecting to one of my nodes and I'm specifying the port for the container. And I can connect to that remotely. And I can see there's my database name and the host name is stateful set name or the pod name, not the server name. So it's disconnected for that. But my database name and the size and the parameters are all created at runtime from the variables I specified in my config map. And the listener ports mapping is done for me. So host name equals pod name, not node name. So I have a pod running, I have a database running, I've waited for it to start up and I can see that that's all okay from the Kubernetes dashboard. I can see I've got storage there. Maybe I want to shell into the server. So the shell is a lightweight environment, so it hasn't got all of the commands that we would see in a full heavy version of the operating system, but there's enough in there to do what we need to do. We can use kube control exec, interactive, there's the name of the stateful set, the namespace again, and I'm saying run bin bash. So that's going to give me a shell. So there I've got my shell. I can do a df -h. So I'm on as the Oracle user in that stateful set name. So even though I'm on that server, that's my pod, df -h, and there I can see all of my volumes. And here's my 3 devices that I presented to that are being mapped to opt Oracle all the data for my data files, opt Oracle script startup, my startup scripts, and opt Oracle scripts setup. So all of that mapping's happened for me. So that's using iSCSI, and it's presented those to my container. Okay, so we've just got a few minutes. So let me just show you this. So kube control get service -n, so nothing there, so an empty environment. So let's try doing this. So first of all, we'll get a service. Okay. So get any pods? There's no pods running at the moment. So there's my scripts we talked about. So there's my 18, my 19 scripts. So we do apply -f for the file, and we specify the 19C stateful set one. So this is going to create me a stateful set. So it said it's created, and it's creating me a service. So there was no service a minute ago, so let's have a look at my pods. So there's my pod. Its status is 0.1, so it's starting, it's pending at the moment, and I've got a service. So there's my service being created. So 1521 is my internal listener, but 30,092 is my external facing container. So here's SQL+, that is what we're going to connect to. So let's just wait for our database to start. So this is the very first time it's starting. So we're running the Oracle installer. So what we can see here is the startup going through, and we can see it's directory structure that we'd expect to see for the listener and the alert file, and that takes a while to create that. So it's creating a pluggable database, and we can see it's gone through. So that's finished. That's been accelerated a bit, and there we can see our data files have been created in opt Oracle all the data, which we know is mapped to our persistent storage. So that's created. If I go to my desktop, using the port I got from the service, I can connect to that database and we can run a query against that. And if you see there, notice that the host name is set to the pod name, not the server name. That's good. So we've created a database and we've taken that through. So you want to get started, you want to have a play with this. So I've got a blog, as I say, and you can use Oracle XE. So it's a great way to do this. So Express Edition. So you could do that if you've got an Enterprise Edition. You can also use those versions, but XE is probably a great place to start on your laptop. So visit my blog. I'll walk you through how to do this. So getting started with Kubernetes on Oracle 18c Express Edition. So it uses a virtual box, it uses XE, and it creates a Kubernetes environment. Walks you through that. So it's based on Minikube, and which manages the virtual machine. So on your laptop, you can use the dashboard, we can use the YAML file, and we can see our database being created. We can either do it with the command line, or if you prefer, you can use the GUI, and from the GUI, we can get the metrics of the container. We can also see the log by selecting the container. We can see the logs in there. So we don't have to visit the operating system. You can do that all from the dashboard if that's what you prefer. So I have on my site various manifests, you know, for Oracle 12c, 18c, 18c Express Edition, and 19c. So they're all available. So you can look at those. Also describe how to use persistent storage, whether that be NFS or block. That's all up on my GitHub. So the question I said at the end was, you know, would you run an Oracle database in Kubernetes? So I guess one of the reasons for checking yourself and saying is the right strategy is the support for rack. So so I did say that, you know, Kubernetes is all clouds, but Oracle don't support rack in all clouds. So think about that. Think about whether you need to install it into production. So there may be some reasons why you wouldn't want to deploy rack, but definitely have a play with it. Try it out in your development test environments, but you know, check the support environment before you go into production. And also consider where you're deploying it. If you're running the Oracle Cloud is the only place you can run rack today. So don't necessarily think about running Kubernetes in AWS or another cloud just because you want to try it out Oracle Kubernetes, because it won't be supported. So should I run my production database on Kubernetes? If it's a single instance, if the workload is right, if you have the demand, if you understand the requirements, you have the technical skills to do that in your organization, yes, it's supported, and it can be a good solution for some lightweight databases. If you need a heavyweight database, question why you're doing it. Make sure that you understand the support and the way it's going to be used and how it's going to scale. If you want the flexibility, if you want to be able to clone into development test, it may be a good option. But if you need to have the scalability and the HA that rack provides, it's probably not ready for you today. So that's my end of my presentation. I hope you've enjoyed it. I think I've recovered a bit of time for the next speaker. So that's me done. I will now look at the chat box to see if there's anything in there.
Excellent. Thank you, Ron. And thank you, everybody, for joining. If you do have any questions, please feel free to add it to the question box there. Let's have a quick look. I think there's one. So Ron, here's one question. Let me just have a quick look at it. Yep, so the question is, do you have a view on the licensing impact for Oracle database work on Kubernetes?
Yes, so when we look at Kubernetes, Oracle doesn't today acknowledge the soft partitioning, whether that be virtualization, containerization. So the best practices you have around virtualization and VMware and other technologies like Hyper-V are still true. So speak to your account team, make sure that you're compliant. You know, today you license CPU counts, so you have to understand how you're using those. So if you have a small container but on a large box, you're probably having to license the whole box. unless you've got something else and on top of that, which is going to restrict the CPU count. So Oracle Virtual OVM, Oracle Virtual Manager, that is considered to be a compliant licensing tool, whereas VMware, it's up for debate by some people about how you could do that. So with DOS and affinity rules, but we can't do that from a containerization point of view. So you need to do that in the guest operating system, which is hosting your Kubernetes environment. So it can be done, but yes, make sure that you understand that before you deploy lots of containers on a big box and realize that you haven't got enough Oracle licenses.
Thank you, Ron. That was an exciting, interesting presentation. I really enjoyed it. I hope everybody that attended enjoyed it as well. Please feel free to communicate with Ron. There is various different channels, and he mentioned his blog. I'm definitely going to have a look at that. Also, just want to say, please register for the other sessions. There's quite a lot of sessions, as I mentioned before, that's running over the next few days. So please register for those sessions as well. There's some really cool ones there. And again, the session is being recorded, so you will have 2 weeks for the session to review the recordings as well. Thank you so much for attending today, and I hope you have an awesome day. And thank you so much, Ron, for presenting.
Thank you. And yeah, all enjoy the rest of the conference. And hopefully I'll see you in person one day soon. Thank you. Bye-bye.
Bye, everyone.